Okay, welcome to the Automate Construction Podcast. Today we're joined by Fabian Myers-Brotz. You may remember him from the 5-unit apartment building in Germany, or the 2-story, the most innovative 3D printed house in the world. Fabian is a construction innovator and the champion of 3D printed construction at Peri. Welcome to the podcast studio.
Hello, Jared. Thank you for having me.
Yeah, yesterday we were at your most recent project here in Houston. You're building what will be the biggest 3D printed building in the world. And recently you've also been promoted to CEO of Peri as well, Peri 3D Construction Division.
Exactly, sir. Yeah, we have been carving out our 3D printing business from our headquarters, and I have the pleasure of being the CEO of that. And indeed, yesterday we have had the pleasure to unveil the construction site of what would probably be the biggest residential home that has ever been printed. Mm-hmm. And more particularly, it's going to be the first 2-story building in the United States that has been printed.
Yeah, there's other buildings which are 2 stories that include some 3D printed features, but they don't have any 3D printed parts on the second floor. So yours has already reached 20 feet, and it will ultimately be 40 feet with the fireplace that included. So incredible scale. And you're working with Hannah Architects. Who are the other groups involved?
So we the 3 main partners for the project, apart from Peri and Hannah, with 2 amazing architects, is CIVE, who is a local contractor here in Houston, who also provided all the engineering services that we need to make such a structure happen. Awesome.
So when, I think you mentioned it was 2 years ago you met Hannah, and that was the first ideation for this project?
Indeed, 2 years ago I met Sasha, who is also, again, a professor at Cornell University at a scientific conference. And at the time already, 3D printing had been around for decades, right? So, but we always felt that there is a big difference between stacking a couple of layers of concrete and actually making this happen as a complete holistic construction process. Mm-hmm. And that's always been what's been nagging us, and we wanted to prove that can be done and how it can be done. And we've been hard at work ever since with a lot of tough planning that went into it, with all the little details of the overall construction process that we tried to figure out before actually starting to print.
Yeah, I definitely want to ask about some of the more recent challenges contemporary with that project. But before that, since it's the first Peri representation on the podcast, I know Peri invested in Cobod pretty early on. Were you were part of Peri back then?
I was actually also the person who basically drove mm-hmm. that investment story. But if you don't mind, I can tell you
Please.
A little bit more of the story about how we got into it. I mean, Peri, we are the world leader in formwork and scaffolding solutions worldwide, with more than 70 subsidiaries across the globe. Also a very strong presence here in the US. And formwork has obviously been the predominant technique to shape concrete, right? So formwork left, formwork right, concrete in the middle, and once it's cured and hardened, you remove the formwork. And we as humanity have been doing that for thousands of years. I mean, the Roman did it that way. But we're still a 100% family-owned business, so we always have a very long-term view on technology and innovation, and not just profit in the next quarter. Mm-hmm. As such, Peri had decided that we need to focus on more of the disruptive side of things, so not just making things 2% faster and 3% cheaper, but really changing the way we build drastically, because as we all know, we have these huge societal challenges ahead of us. And to put it in a little bit more simpler words, we said, okay, if there's a technology out there that can shape concrete without the use of formwork, we might be out of business. Mm-hmm. And if somebody's going to destroy our business, it better be ourselves. So we don't want to wait. We don't like that. We'd rather than be at the forefront of it. And that's kind of how it all started. Even before the investment in Cobot, we've been active in the field of 3D printing. But then we've seen that that was back in 2017, that it already had matured faster than we had initially envisioned. Mm-hmm. And that led us to travel quite a lot, see a lot of the startups out there back in the day. I mean, to visit all of them and see who do we want to work with, who do we feel is the right team with the right mindset to make that happen.
That was a much easier task a few years ago than it is today.
It was also a little bit of a cheaper price tag, but obviously it was by far not even envisioned that the market is going to be as significant as it is today. And then I met Henrik and his colleagues. I believe that was actually shortly before Christmas in 2017 for the very first time. We then continued the conversation and ended up being the seed shareholder with a minority investment in Cobot.
Let me get the coffee. Okay, so you became the seed shareholder and minority investor in Cobot. And what was that process like, convincing because Peri's like you were talking about, the lead formwork provider, a big serious construction company. Most construction companies are slow to adopt innovation and change. So what was the process like convincing the family that owns it to make this investment in the future?
Well, of course there was some convincing that had to be done, but I wouldn't say that it was an awfully difficult journey. Again, innovation has always been in our hearts, and we as a whole company, it drives what we do every day. And in fact, this mindset of disrupting our own business has always been around. If I may give you a very simple example, I mean, we sell formwork, but we are hard at work to invent or innovate formwork solutions where our clients need less of them. So creating products that our clients in the end need less of actually has made our company successful in the long run. And so this has always been at the heart, definitely that convincing story wasn't all that difficult. I would still say though, when we got started in 2017, 2018, it was obviously a bit of a bet, let's let them see how it goes, and if it doesn't work out, then it's not all that bad. But obviously I think we've come a long way since then, have been successful and have been growing substantially as well, have been able to prove what this technology can do, and also what it can't do, and that's, I think, the bottom line.
Yeah, it certainly can eliminate the need for formwork. I mean, you've seen that on multiple projects at this point. And so I guess the pitch is coming on as a threat, as you were saying, like our whole job is formwork. So if a technology can remove the formwork, it just makes sense. And I guess most of the sales pitch came in convincing them to let you do the traveling to visit the different companies. And at that point, they were probably prepared to invest in one.
Exactly. At that point, it was already clear that we had a certain budget to invest, and that in that range, I had the freedom then to make my decisions. So that has been clear already. But let me add that, I mean, yes, the Peri-centric worldview about it is obviously kind of, we do formwork and it might replace this. But there is that broader view, right, that we just, as one of the leaders in providing construction technology to the industry, we almost have a responsibility to tackle some of these societal challenges, right? That we can build better and hopefully faster, and can provide more housing in less of amount of time. And so these challenges, we have to tackle them, and we want to play our part in that. Yeah,
and with early technologies, could you repeat the analogy to the LED lights you brought up?
So I've been, even before my time at Peri, I've always been involved in innovation and long-term views on it. And from my point of view, innovation mostly starts in niches. And those niches are, I mean, you could take a smartphone or an electric car, but the example that I like a little better is LED lamps. They've been invented decades ago, and then decades later we were able to see them in very specific applications, for example in the medical field. And now you can buy an LED lamp for a couple of bucks at IKEA, right? So it always took a while until these innovations make it to the mass market, and this patience needs to happen in the construction industry as well. We cannot expect to do something radically new and right off the bat we're better than technologies that have been around for a long time and have the opportunity to become more efficient and more efficient and more efficient. So we have to just acknowledge the reality of it, while still obviously having this greater end goal of where we want to be.
Yeah, from a distance, these things seem like magic or taken for granted, like LED lights, but somebody has to pursue those innovations and make all those step changes to bring it to that level where it's cheap, and you guys are playing a big part in making that happen. So the early prints, what's changed from, say, the first prints you did to, was the house your first print? You got the printer, I assume you started with some smaller objects?
I mean, yes, we did, of course, do a lot of testing as well. I mean, the first two-story building that we've done in Germany had to go through quite a tough permitting process.
Yeah.
We have one of the most difficult building codes, I think, in the world, maybe second to Japan in Germany. And so definitely not our first print when we got on the site. That's not the case. But still, once you actually do go out there on the site to fight with the environmental conditions, with the material logistics on a larger scale than we had in our lab space, these were definitely some of the core challenges that we had to overcome. But then again, I mean, the printing of layers is always just one thing. We've learned so much about quality assurance, about how do we integrate rebar, how do we integrate electrical insulation, and how do we make sure that the structure also has a good longevity. I think these are the things that are more important, and sometimes, I mean, the 3D printing has an option of influencing the whole construction process, but sometimes in other projects we see that it seems to be focused very much on the walls itself.
Yeah.
And we have always wanted to not just tackle the walls, but really think about the holistic process.
Yeah, definitely. And I see that there's some projects that just try to make a 3D printed house happen in the quickest, easiest way possible. But as you're saying, it requires improvements. And so if you're not exploring, then it's a waste of an expensive project. So if you're trying new things, integrating technologies in ways that they're working together with 3D printed construction to make the other trades easier, that makes a lot of sense. So when you approached this new project, one of the main differences is it's not one monolithic structure. It includes some timber frame construction. Were these decisions made for practicality or on the architect's whim?
A little bit of both, I would say. I mean, in the projects that we've executed years ago in Germany, we've printed every wall, right? Every load-bearing wall, non-load-bearing wall, facade element, everything. Also to show that we can. But the question is then always, if you do a post-calculation and then you ask yourself, does it make sense to do this? Again, in the overall scheme of things. That is one issue where we thought, okay, let's put the concrete to use where it's best used, and that is in its structural capabilities. And in instances where we don't have any structural need, why would we use this very strong material, right? So that is one aspect. The design of it, the combination of different building methods, that definitely came into the equation. And maybe a third point is that we've learned from our project that we did in Tempe here in the States as well, right, to cope with the blistering heat. And again, we've printed this now here and also in Texas while it was really hot. The sectioning of the building plays a really important role to be able to navigate those ambient conditions.
Yeah, the heat is not to be understated, especially in Tempe. When I was filming there, my cameras were overheating. I had to leave the AC on in my car and just switch cameras, leave one in the AC before it overheated. In Houston, it was a little less hot, but certainly it's still like high 90s, hundreds in the midday. And in Germany, it's the opposite. While you were printing in the winter, there was snow falling.
Yes, sir. We like to set up ourselves for a challenge, right? I mean, we distribute the Cobalt technology to certain selected markets. So, for example, in the States and also in Central Europe. And when we want to help our clients with a full suite of services and knowledge that we can provide. So we don't really feel comfortable to let the client go out and do stuff that we potentially have never done ourselves before, because then our help is a little limited. So every project that we've done so far has been about setting up ourselves for a new challenge, about learning. It's never been just about this repetition process, right? And that's why we wanted to do it in winter in Germany, very purposefully. Tried to push the boundaries there, and found out that we got it to couple of degrees below freezing. We were able to do it, but it was really tough as well. And now we did it here again in the blistering heat. In Tempe, we've learned a lot about this, so that now actually in Houston we've been able to cope with it a lot better, which I think the layer quality is the best evidence of.
Yeah, a lot of groups compensate for the heat by printing at night, like they did with the Avis Core building in Dubai or some of the other projects where there's been a lot of heat. But you didn't have that luxury because you're printing in a pretty dense residential zone. So you were printing during the day, exposed to sunlight, exposed to the heat. Even yesterday at 11 o'clock, you were printing with a big media day event. What have you had to adapt? In the past, some prints exposed to sunlight have had cracking issues, but the house you're printing recently remarkably has very, very little cracking.
Cracking is definitely one of the biggest issues, I believe, for a technology right now, and it takes quite a few things to make sure that it doesn't crack. Of course, the material itself plays an important role. Where in this project we've been working with Quikrete and again have been testing that significantly before we even went out on the site. The sectioning again plays a big part, that you really ensure that the next layer comes on top in a decent amount of time to create the next layer of moisture basically. Curing is always an issue that you incur, but that's actually not too difficult to solve in the end. Expansion joints is the last one on the list that really helps, that need to be integrated. But one remark as well is, and I think maybe actually you know more about this than I do, is that I think there's always two issues with cracking, right? There is one that happens hours, maybe a day after printing, and then there is cracking that happens over the lifetime of the structure. Because when you've had the first summer or the first winter and the structure's been around a while, maybe the foundation moves or all these different factors that come into it. So obviously now we've been in the project here in Houston with the first type of cracking, we've been very successful, and with the second type of cracking we'll see how the structure, again we've tried our best to ensure that, but let's see. And we try to be as open as we can. I mean, all the projects that we've done, they're out there. You can visit them, you can see them from the outside. We very purposefully didn't plaster them or try to hide anything. And that is important to us, right?
Certainly. The Heidelberg versus Quikrete material, when you're working with different materials, they have different properties, especially when you're sourcing aggregates in Germany versus the US. You probably want to source as much locally as possible to reduce the expenses, and Peri having a headquarters here in Houston, anticipating further prints, I'm sure they had that in mind. So were there differences in the way you needed to treat the material while it was being mixed, while it was being printed?
Yes, definitely so. I mean, that is one of the beauties of the cobot machinery, right? That it is material agnostic, and it's also the beauty of the MTech mixing system together with our proprietary silo that we're using. We've tried to supplement the cobot machinery with the right framework around it, so that we can really use various amounts of material. And there really the devil is in the detail. So even the geometry of your mixing device can play a significant role in your material properties. And these things have to be again tested. I'm saying this word a little bit often, but I think it's important. So the mixing device, of course, even the water temperature might play a role. The amount of water, definitely the hose length comes into the equation. The aggregate size plays a role in what type of pumping system you're using. Layer time, layer width, layer height, all of these factors have to be adjusted based on the material. It has to be done, but on the other hand, it's a doing. It's not something that where you say, okay, I'll not be able to figure it out. So we've printed with so many different materials by now, and we know that you can make it happen.
Do you get a sense for the amount of room for improvement in 3D printed construction versus traditional formwork?
Tremendous. Formwork there's still a lot going on also in that world, and how to bring more digital solutions also to the formwork. But nonetheless, we are, with every structure that goes up, and I think that's not just true for us, but for the industry as a whole, right? It's making jumps and leaps every year. The progress that we can make is there will be so much going on. But the most simple example that I like to make is the layer height. Most structures that we've printed so far as a real world project have a layer height of a little less than an inch. But in our lab space, we've also been doing close to 2 inches, right? So, and that obviously basically cuts your print time in half. So that's just one very simple example of how we can make jumps and leaps here.
That's a seemingly good move to increase the layer height. Would you consider increasing aggregate size as well?
Definitely. That is, again, I think the whole 3D printing industry is aware of what aggregate sizes brings to the material costs, to shrinkage, to compressive strength. It's just a matter of time to make that happen. But you have to always kind of start at one point and then see what really is painful in a project. And that's what we always say, we need this minimal viable product that we can start off with to learn. And then we see where the biggest pain points are, and then we tackle those. And aggregate size is one of them. But nonetheless, there is not a one-size-fits-all, right? There will be projects where a lower aggregate size makes sense, and then there will be projects where a larger aggregate size makes sense. And this variety is such a beautiful thing in this technology of 3D printing that we can accommodate for all of these different types of projects.
Yeah, certainly. Not to mention like geopolymers or hempcrete or whatever other solutions people may come up with in the future. Probably something we haven't heard of yet. What would be the scenarios where you'd prefer a larger aggregate or prefer a smaller aggregate?
Obviously, when we need more concrete because of the structural capabilities. For a 2-story building, you can print rather narrow layers. But the taller we go, or the more structure we want to put on top of what we have printed, then we'd like to print in bigger layer sizes, and then the larger aggregate size comes into the equation. That's definitely number one. And I think for projects that don't quite have that aesthetic aspect to them, where the visual aesthetics of the layer plays such a big role, the larger aggregate size can become more attractive.
Yeah, the project you're doing now includes a lot of overhangs and angled prints. Is that an example of a situation that's preferable to use mortars?
The mortars have a capability of doing more inclination so far. That can also change. But I think with the overhangs, and also if we really want to leave the layer structure exposed, we don't want to plaster it, not even on the inside, right, to leave it exposed. Then with the mortars, you have a very smooth control of your material, and then that can be very helpful.
Yeah, it's a nice thing to be family owned rather than a public company that has to worry about making quarterly profits, because it affords you that long-term perspective to test all these things out. And back to the cracking for a second. Some people, traditionally the mantra is concrete. It's a matter of when, not if it cracks, or maybe it's 70 years, maybe it's 200 years, but it's eventually going to have some type of, maybe it's a hairline fracture or something. So your structure has some poured columns with rebar, and so even in the scenario that there is an aesthetic crack, it's unlikely to sacrifice the structural integrity of the building, correct?
100%. We pay very close attention to that the structures we do right now, they are 100% safe and sound. They might be a little bit over-engineered because of that, but we've tried in a lab space to prove the longevity of structures by doing freezing and thawing tests, for example, but it's still in a lab space, and there haven't been 3D printed buildings around for decades, right? So on this side, we'd rather be safe than sorry, because I wouldn't be able to look myself in the mirror in the morning if something happens to an inhabitant of such a structure. So it's a slightly over-engineered on that end for now. But you're perfectly right. Concrete any type of concrete, even the conventional ones, and no matter what rebar or fibers you use, it will crack. You just need to be careful that it's neither structural, and it also doesn't like hurt the integrity of a building in terms of water protection. That water doesn't get into the building. As long as you've taken consideration of these two factors, that's fine. But that's what we are now we are monitoring every structure that we've printed very closely every year to see, has it moved, what's happened, and why.
Yeah, you've only been here on this trip a few days, but how do you like Houston?
Well, I'm a small city person myself, so given this, the big sprawl of Houston is always a little difficult for me to navigate, and then with 10-lane highways.
Yeah, bumpy roads too.
Yeah, that's true. But I think the city itself, I've had tremendous food in Houston. I really enjoyed that, and the way that the city is progressing and growing is really nice. And we've just found the right partners in Houston to make projects happen, and I think that's very, very important. And I like that mindset here, and with all the partners and all the local people that have been involved in the project, and that is what I appreciate very much about Houston.
Cool. What's the Peri operation in Houston like?
So we have a warehouse here in Houston, of which we are operating our 3D printing business out of. We've been growing the team substantially, but it's still a small team right now with 4 people here in the US, but still growing the team, still looking for the right people to grow it. There I'm always very adamant about that HR or sourcing of talent is really important, and we'd rather take it a little slower, but then we have the right people for the job, and the team here with my colleagues Roberto and Sam and Hector they're just doing a tremendous work to making this happen here on the ground. In our warehouse we have a printer that we can use for testing, we have the spare parts there, etc., so that we can help our clients locally, and that we don't have to always ship things from Europe over here, which then makes the lead time longer, etc.
You even shipped your printer over from Europe. It was the same printer you used for those other projects.
That is very much correct. The printer that was used to print the very first building in Germany is actually the printer that is now printing here in Houston. Most likely, though, it will be the last time it's been out on a site. It will now be going into lab space and stay there, because Cobot has been making a lot of improvements to the gantry system itself. And we have the newer printers arrive here as well, so that we can utilize those also in our rental project for our clients.
Nice. Cobot did a good job. I know they provided a lot of updates to your printer throughout its lifespan. The new printer, I guess there's some changes that can't be retrofitted.
So to our knowledge, actually it can. So we've actually done a lot of retrofitting as well to some of the lab printers that we use. And I appreciate it very much about the Cobot team, that they have that in mind. They have in mind also their existing client base that might have, older printers. They're not really old as such, and that they can get those upgrades. But even nonetheless, I mean, obviously the printer that is out there in Houston, and you've seen the quality it produces, right? While it's one of the older ones, it still works and still does its job very nicely, right? So, given this, the upgrades are helpful, definitely, for sure, but you don't necessarily have to have them to produce good quality products.
What kind of upgrades are you looking forward to? I know the hose management system has been improved a bit.
Hose management is part of the issues but unfortunately, I mean, we have a big fair coming up, a big exhibition event at the end of October. So I hope for your understanding that I can't talk all that much about the new things that are coming up. We will showcase them in the end of October at Bauma.
Great.
And then I'd be happy to have you there and share a little bit more about them at that time.
Awesome. So are there other projects is there anything you're able to talk about the future in Houston perhaps, or in the United States?
We're not big on announcing things. I'm not a big fan of that. I always like to speak about it when there's actually a printer on the site and there has something being printed, because things can happen, right?
That's probably smart. I'd say like 1 in 10 of the projects I hear about actually end up becoming built, and so sometimes it's a challenge. If you want to 3D print a house, you can, if you have a specific location that you want to print a house, maybe you can't. There's it's restrictions, municipalities, permitting. Houston has no zoning laws, so that's a little bit helpful, but you still need to win permits. What was that process like with the Houston District 8 municipality?
It was definitely more difficult than in a smaller municipality. They have a very professional setup here in Houston about that, but we went through the normal process of handing in the construction documents, going through a revision, and then we did the changes, we answered the questions that were out there and put it up. I think the difference is always in terms of a conventional structure that we highly recommend to involve the municipality or the building authority at a very, very early stage.
Yeah.
To educate them on what it is that we're doing, to have them while we are testing something so that they can contribute. Because in my experience so far, I've not seen a municipality in all the countries that we've been doing it that isn't helpful in a way. They also have a deep understanding that we need to change something in the construction industry. And so also here in Houston, the conversations have been very much on eye level, and we've been having good discussions, and they gave us also good feedback on things that we could change or do differently to make it better. So I would always say, don't be afraid of this, of talking to the municipalities. It's not it's something you gotta do, but it's not a huge hurdle to take. It can actually be very helpful if you try to really involve them.
Yeah, and all the early projects you did, they were huge learning experiences, and now they're good references to have. You can show them you've done a 2-story 3D printed house before, rather than trying to convince someone it's possible before it's ever been seen. So were you able to pull some of the documents from the Germany permitting and use that as a demonstration for them?
Little, actually, and the core reason is, as you mentioned earlier, that in Germany we've been using the Heidelberg material and here the Quikrete material, right? And if you change even just sand and aggregates in a material, it can change the properties quite significantly. The concrete scientists know that very well. So even if you go from one plant of production to another, things might change. They don't have to. And given this, we had to really reiterate some of these things, but we knew how. Right? We knew what we would have to be looking for, what would be critical to test, and that was the huge learnings that we were able to bring from Europe to the States. We weren't just doing tons of tests, and some of them then didn't really create value, but we were more focused on the critical parts.
How much material testing is required throughout the actual print? Is it like one per day, or?
Well, I think there is a difference, a little bit of what is required and what we do. We always like to print a couple of pieces on the side that we can then test a couple of weeks later, and some of them even a year later, right? So that we can really monitor how the structure is doing. In Europe, you have to do that, even with a conventional concrete structure. In the States, that is you have a little bit more leeway on that, but still, this is something that we recommend. So again, it's not just about what a municipality might want, but it's about creating that learning. I mean, it's exceedingly interesting to say, okay, this is a structure that has been printed in the ambient conditions of the actual building, and a year later we can test it and how it performs a year later.
Yeah. I read through AC 509, which was developed by Contour Crafting a long time ago, and it seems like it was made to ruin 3D printed construction for the rest of time. Like, was that paid for by American formwork companies or something? I don't know, but it's great to see that it's not, you guys have been able to circumvent some of the, like it says you can't have 2-story residential structures. Why not? If you can build a 1-story residential structure 20 feet high, why not put a floor system in it? So was that something you had to fight against or ignore completely?
No, I mean, we took it into consideration, and we've also made the municipality aware of these documents, right? If they find them themselves and they have the feeling that we try to hide something from them, that wouldn't help. But we feel, or I personally, that this is now a very subjective opinion actually, from me personally. I think there are instances that other construction methods have also taken decades to make it into the American concrete code. if I'm not mistaken, shotcrete actually made it into the concrete code like in 2019 or something like that. So like it's been around since the 50s or something. So then it takes a long time to make it actually into the code. Luckily, I mean, in the US you call it the alternate methods and means, right? So there is always that little paragraph that tells you, look, if you wanna do something differently than this code tells you, you can, if you can showcase that and back it up with data.
Yeah.
Right? And I think that's what we need to do. And there are some very exciting norming initiatives out there, right? All driven by Stefan Mazur, for example, and we're a part of that. But those will develop over time. And I think everybody's aware of that. We now need to try to put a little bit of a guideline in place. But this guideline will not stay like that in the next years. It will change. It will adapt. So I think it's good still to have these documents that can give you a wide array of input in terms of what you might want to look for and what you might want to test for. And then in the end, you still have to take your individual project into account.
Yeah, Stefan's doing a great job. My favorite part about it is instead of having one little paragraph at the end, it's built with the intention of being able to test new things and explore new possibilities with a rapidly evolving technology that you can't really define in the present tense for how it may look in the future. I didn't know about that last paragraph of AC509, so that's good to hear. And it's like, I guess, almost 20 years old. So even with Cobod adding new improvements to their printers, how could such an old regulation apply to a new technology? Maybe that's why Europe has always led like prefab, and even when the mass timber was a big new thing, that was kind of led by Europe as well. Will Peri be doing many more printing projects in Germany, around Europe?
We have several projects lined up in Europe as well as in the United States. But I need to always point out, right, we don't see ourselves as a construction company or as a 3D printing company, that we do the printing ourselves necessarily. We are doing it because as we believe you wanna buy a machine from somebody who's used it extensively, who has that knowledge not just in building the machine but actually how to use the machine. So the projects that we do as Peri always have this innovative mindset and trying to push the boundaries. That's what we're in it for. So to create the learnings, to understand how do we need to improve the technology, how do we need to improve the process, what can we do to increase the scale of the structures we print, or that then our clients can print. So this is definitely again important to point out. I mean, we're now delivering printers to our clients here in the States, and then we can use all those learnings to help them and that they can hit the ground running.
Do you think you'll be using the Cmex material?
It is definitely an option. This one again very much depends on the municipality and the regulations, because it's obviously amazing to use the very 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 local ingredients. But the quality assurance is then always something that one has to take care of, that you yourself have to do. If you buy material, in our case now from Quikrete, that is already pre-blended, they do the quality assurance. And that's, I think, the different aspect of it. And that's one thing. And the other is our site right now in Houston isn't the biggest site, right? I mean, the structure itself is fairly large, so there isn't all that much space around it. And I believe, again, not one size fits all, right? So if you do a residential project and you want to print quite a few structures, the Cmex solution that Cobot has developed together with them can be very beautiful. If you do one very bespoke structure, the prefab material or the premixed materials might make more sense, and we can do both.
Yeah. You were mentioning you're always looking for people to join the Peri team. I like to think that there's some pretty intelligent 3D printed construction enthusiasts listening. What would the ideal candidate look like?
We always look for people that have that passion for what it is that we do, right? We want to change the world, we want to make it a better place. We are in the intersection of various, let's say, engineering fields, so to say. And none of our people that we have in the team have had this expertise from the start, right? So as long as you are basically joined in our vision and mission in changing the world and how we can do this, this is the core thing that we're looking at. And apart from that, the engineering background, if it's now whatever, architecture, material engineering, mechanical engineering, but also, I mean, we obviously don't just have people that have a university degree. We have lots of other people that have learned their trades. And in all of this, the important thing is you need to burn for what it is that we're doing.
Quite literally, when it gets hot out in Houston or Tempe, will you do a lot more? Do you anticipate being printing in hot regions in the United States? Will you be printing in cold regions in the States?
We will do both. I mean, we also have a couple of clients up north in the States that we're working with. I foresee as most of the most growing metropolitan areas in the States currently are located more in the southern parts, right? If it is now whatever, Phoenix in Arizona, or Orlando in Florida, or Houston, Texas.
Yeah.
So I think the warmer climates will be more prevalent.
Yeah.
And also in the States, I believe, I mean, one of the upsides of the technology is the resiliency that we can provide, right? And that is also more important from my understanding in the more of the southern parts where you have more of natural disasters coming in every now and then. So here the USP that 3D printing can bring is even more important.
Yeah, those natural disasters seem to be scaling up too, so it's probably a good thing long term to have things a little over-engineered, which the 3D printed construction techniques with also having structural rebar, poured concrete, they usually have that. You mentioned that Peri doesn't intend on printing all the projects for the future. What does the long-term business model of the Peri 3D construction division look like?
So we are, again, a provider of technology for our clients, right? So we sell equipment, we rent equipment. So far we have limited amount of printers available for rent, but they're here, so that we can do that. So for our clients that don't necessarily say want to put down the cash for the machine, but they still want to give it a try, that we can help them out that way. And again, all the services around it. And this is very much in line with our core business that we are in our formwork and scaffolding business. I mean, we have just in the United States, we have several yards spread across the country, so that we are available and can help the people also in their region with the specific parts that they need.
That makes a lot of sense. It fits the traditional construction model. Few GCs own their own equipment. They'd rather rent it for the time they need it. And so many people have been asking if they can rent a construction 3D printer, but as you're saying, like there's so few of these machines out there right now. Even though there's so many more than there were last year, 2 years ago. I know Cobalt has the ambitious goal of scaling up 100% every year, which would put them at like $1 billion in 30 years. But they can keep up with that for a while, hopefully. And yeah, you'll have a second printer. So the second printer in Houston, that one will be rented out?
That can be rented out, exactly, right? And that is the purpose of the machine. We might, again, also use it for a project of our own if it's innovative enough, or we are going to do that, but it is available for rent. I mean, maybe in contrast to how rental works in the conventional industry is that people know already how to use the equipment they're renting. And for us, obviously, the training and that comes with it, always also with the rental, you still need that upfront training, you still need to have that service around it, about the planning side of it. But that's what we're here for, and that's why we're here to help. We want to share our knowledge, and I believe we try to be as open as we can about it, so that we can grow the industry as a whole. There's nothing to be gained to be too secretive.
Yeah, there certainly is that two-step process. It's not just the equipment rental, it's the training and then the equipment rental, and maybe even some support on site.
Exactly.
Potentially renting operators.
Potentially, we call them supervisors, so we do send out people exactly to help with setup of the machine, with calibration, with helping on the site. That is important. I think that is a fine line. If we would send out the operator, are we then all of a sudden the contractor that we actually don't want to be? That might be a little bit of a fine line that we need to figure out in the individual project.
Yeah, it seems Cobod, when they sell a printer, they usually have some operators go out just to help with the first print as like a testing process. Do you think it would be more streamlined than that, potentially video only, and then they'd be able to get started on their own, or is that hands-on in-person training really required?
I think for the time being, the hands-on in-person training will be required. I mean, yes, you can do a couple of upfront things, of course, digitally. I mean, COVID has proven that a lot of things can be done remotely, and that will continue to be so. But some things you just have to see, or you have to touch the material to have an understanding of what's going on. And that's why we have created our team here in Houston and aren't saying, look, we are going to do all of this from Europe. No, we need people locally here that can be with you in a short amount of time to help if something is wrong.
Yeah, I did an operator training with a different company, and it was very qualitative. So when the material starts coming out, at first it's just the water going through, and then you start to get some of the powder so that it's not all the powder at once clogging up the machine. And then it was just touching the material and trying to feel if it had a solid core to know if it was ready to be printed. Is your process similar to know when the material parameters are right, the water to powder ratio? How do you test if it's ready to print?
I mean, we do measure it, and again, we will showcase a little bit more about that at the Bauma. But yes, there is measurements involved. Let's say the eyeballing of the material is still something that an experienced operator can do. So they might not even need to measure it. They will be eyeballing it, say it's fine, and the measurements will then just be able to document it potentially. So I get that process of feeling and touching and eyeballing, because that can be very, very valuable to the process. Still, we like to be able to, in particular, again, to document the quality in every single layer. If one layer isn't good and the adhesion in that one layer, that will be very detrimental to your tensile strength. So to really make sure of that, that you can't like eyeball your material every second. Right? So that is something that we need to measure differently.
Yeah, keeping the material consistent throughout changes in temperature, sunlight throughout the day, requires some adjustments, right, to the water ratio and additives. Although you said they have a ready mix solution, are there still liquid additives included or accelerants?
So in the project that we're doing now here in Houston, no. But you can do that also with the Cobot machinery. You can introduce liquid additives if you need to. But the water content is one of the things you can change. Obviously, concrete scientists don't like to put a lot of water. I mean, the more water you put into it, the less strength, the more cracking. So we don't really want to play around with the water content too much. It's in a rather narrow space. But of course, with the pumping, the frequency of the pumping, the frequency of the mixing, the print speed, the extrusion rates. So there are quite a few other parameters that can be adjusted. I still believe that in a good printing process, if you print 6 hours a day, you shouldn't have to change any parameters more often than maybe 2 times a day. Otherwise, something is not quite right in the process. If you have to change it more often, then the process is at fault. That is at least how we see it. We want to have the machine really run, and our people more or less just monitoring it, or be able actually to be freed up to do other work while the printer is running, right? And not just be continuously messing around with parameters.
What are the key measurements that define a material as printable after it's extruded? So besides water content.
So we don't go as much about the buildability as for example, with a robotic arm printer, where you have a smaller print area and different applications than we like to tackle. You obviously go up in height very much, so there the buildability is very important, as we are going more into the horizontal direction in our prints. The buildability isn't the most important part. I mean, the rheology and the viscosity of the material.
You mentioned you're looking less at the buildability because of the size of your print, and you've managed to cleverly space out even different objects, and with your start-stop function you're able to move from one object to the next. I guess it's like 15 to 20 minute layer time is ideal.
We actually like it a little longer than that. I mean, 15-minute layer time can be done, but we actually again like it a little longer, and because we like the robustness of it. I personally have not seen any type of machine or process that always works perfectly, and that the same is true for 3D printing. And if something goes wrong, you want to have leeway. You don't want to then say, okay, something is wrong, I need to flush everything right now, or everything will be clogged, right? So, but you want to be able to say, okay, let's move the machine to the side, have at least a couple of minutes, what is going on, what's wrong, what do we need to do, and then potentially just, okay, we can continue to print right away, because the material gives you that leeway. And if you are going for that buildability, usually your material is highly accelerated, and then you do not have that leeway, right? You need to just flush everything right away.
So how much leeway do you get with the stop function? How long can you leave it stopped before you have to worry about clogging in the hose?
Usually 15 to 20 minutes if you keep the material alive a little bit. I mean, if you try to move it either back and forth, or you try to at least move it every now and then, that is usually a leeway that you can have with most of the pre-blended materials that are out there.
Yeah, that makes sense. So you keep the material in motion while it's in the hose, and what's the upper end of the layer time before you risk not having a monolithic segment?
Very dependent on the material that you use and the ambient conditions, but ballpark wise, roughly half an hour. That's so, and again, like, that's probably where you were coming from with maybe your 15 to 20 minutes layer time. That's what you might want to plan for, so that you still have the additional leeway in there as well. There is a lot of safety in that. Most likely, if you would test the adhesion in the layer time in the lab space, you might come to the result that you have a 50-minute layer time. But on the site, we'd rather than still calculate with significantly less, so that we can react, or that wind and sun, etc., is also incorporated in the process.
Do you ever try to simulate sun in a warehouse scenario?
Yes, sir. We have, and then also rain and also wind. But that is still a lot of effort to do it. Number one, and obviously the permutations of all of this, right? To say, okay, we have temperature, we have wind, we have rain, we have sun, and all of those in different degrees, and then you permutate all of those, and they have thousands of different scenarios that you would have to test and go through. So that's always a little difficult, so we'd rather test a couple of those scenarios and then include a bit bigger safety factor, like it is usually done with concrete materials and other testing approaches, and that's the way we go about it.
Yeah, in places like Florida, you could get almost all of those things in like an hour or so.
Agreed, yes.
Houston is a little less fluctuation in the weather. In a rain scenario, I guess if the layer time top end is like 30 minutes, 50 minutes, that would be enough time to prevent rain from detrimenting the structure? Or?
So if it rains a little, that's usually not a problem whatsoever, and in fact it can help a little bit with the curing of the concrete. If it rains buckets, nothing happens on a construction site if it rains buckets. It doesn't matter if it's timber frame, printing, whatever. So if it rains buckets, you don't want to be printing. We've had the pleasure about 2.5 years ago to print through a hailstorm once, and we actually did print through it because it was like the last 3 layers of a story that we wanted to get done. So it worked. It did work. It was everybody was drenched, and I don't want to do it again. But it can be done. But again, very dependent on the material as well. There's material that have hydrophobic properties integrated into them. Then you might have to pay a little bit more of attention that the water is not between layers, but incorporated kind of into the material. So unfortunately, a lot of dependency is there. There's not one truth that really work goes into it, and then that's why what we're here for, to help and advise.
I noticed at the media day after the print, they were spraying it. Was that water to keep it hydrated, or a chemical to help it with curing?
That's water that has been used. So, I mean, there's for curing you can put something to cover your material, right? But if you put weight on your concrete material that's just printed, you run a little bit of risk of it slightly dropping, and that's not a huge issue, of course, but it can happen. So we've run that process of misting it for a couple of minutes, and then a couple of minutes later it does have that little bit more strength that we need, then we can cover it and then we're good to go.
Yeah, it's so interesting how it takes hours. I mean, for a huge project like the biggest printed house in the world, you mentioned something around 200 print hours you anticipate. But that's such a short amount of time compared to the lifespan of the concrete. So it's really the way you're treating it in that 200 hours that dictates its longevity throughout the whole thing. I noticed you weren't using a tent. You had one side with a wall. I guess that helps a little bit with the sunlight, but not when it's right overhead. So how is that?
We feel that if we have to cover the structure that we are printing or the print area, that obviously adds quite a tremendous cost factor to it. If we would have found out in some of our earlier projects years ago that we need a tent to be able to successfully print, I think that would have put a huge dent into the potentials of the technology. Luckily that wasn't the case, we like to do it completely outside. We did put up a shade basically on two of the columns, also for our people there to make it a little bit more, but well, it's probably more of a psychological factor that you feel a little bit of shade than it actually helping you with the structure. So you need to be able to do it in all those various weather conditions. Otherwise the technology will not be able to fulfill its potential.
Yeah, it's the possibility of more automation on the construction site is very alluring to a lot of people. And I believe based on the Nidus printer they have from Cobod, they were able to reduce the need for somebody to be manning the chain or the hose management system, and some more things that could possibly be automated. I'm just speculating here. These might be some of the things you can't talk about, might bring up a Bauma, but the water being sprayed on the concrete after it's printed, the printer has access to XYZ axis. It can go all around and seems like it would be able to spray water on the system. Another thing is the double epoxy bond after you complete a day of printing to make sure you get a solid connection to the next new layers. Do you anticipate the double epoxy bond ever being automated? Maybe not in the short term, but
I do anticipate some of these things to be automated, but the things you've mentioned, like the spraying of water and the epoxy, that's actually so little value in it, and we feel, I mean, it doesn't make sense to automate everything. Humans are tremendous machines as well, and having somebody go up there for 10 minutes to spray some water or to go some 15 minutes to put on some epoxy, that's the amount of work it would take to automate that, and the additional cost of machinery that you have, from my point of view, doesn't really make sense to then automate such a thing. But of course, there are other things that you can look at, and I mean that's there's various companies who are looking at how can we spray paint something, right, or how can we automate the stucco or the plastering of a structure. Focus for this one is, from my point of view, very detrimental or very important, that we need to we need to focus on certain things right now and do a little bit of our homework.
Yeah.
And not be saying, okay, 3D printing, been there, done that, let's automate the next thing. But there's still lots of work that has to go into the 3D printing aspect of it. Let's get that done, and then we can focus on the next thing. So that is going to happen though, for sure, that we combine different automation technologies on construction sites. We will see that in the future.
Do you think that will come mostly from the equipment or the material side or the software side? Of course, all three.
That is a good one. But I think it will mostly be pushed from the equipment side. But again, you need all three in the end. But I think the equipment side is going to be the side that is pushing for it the most. The material side doesn't really care if it's put on manually or automatically. They still need most likely a similar amount of material, so they will still sell their material, so they don't have a strong feeling about this. But the equipment manufacturers, obviously, they do.
Have you experimented with hempcrete at all, or geopolymers?
Hempcrete, no. Geopolymers, yes. We've also publicized a little bit about that. So we have been printing very successfully with geopolymers, and we are going to continue working on that. It's definitely an exciting alternative. The overall life cycle cost analysis isn't quite easy to make. And the availability of the materials and the quality assurance, fly ash, for example, has a lot of variety. Even if you source it from the same plant every time, you still have a lot of variety, and then you need to adjustments to the mix every time. So these are the things that we need to look at. The devil is really here in the detail, but geopolymers is definitely an interesting avenue for research.
Do you anticipate that being used for residential projects in the near future, or it still has a long way to go in terms of regulating getting consistent mixes?
I think we'll see it fairly soon. The material, again, we've done it, been there, have also publicized it. It's very, very nicely printable. And with 3D printing navigating around some of the codes anyway, it doesn't really matter what we are printing with, what type of material we're printing with. As long as we can back it up with this sufficient testing and data, it doesn't matter if it's concrete, cement, geopolymers, mushroom paste, I don't care, right? So that is again the beauty. We can really think outside of the box and go new avenues. Concrete is available all over the globe. It has a lot of merits. It's very difficult to replace as a construction material, as you know. I think the focus on the concrete side needs to be about using less of it. And if we can manage that, then and add to that the aspects of lower cement contents, then concrete is also a very, very sustainable material to be used, in particular also because you can recycle it, etc. So we need to take a look at the environmental footprint of concrete. It's important to us, but we are not saying that concrete itself is the bad guy, so to say.
Yeah, something a little less talked about is the rotor stators that end up being replaced throughout the project. One group I talked to was saying we're not using rotor stators, and so I dug in a little bit, and it's because they were mixing by hand completely, which obviously isn't very automated. But do you see room for innovation in the rotor stators, or is it a necessary evil?
No, we see room there, that you can do something with it. Although we have to say, I mean, that this mixing pumping equipment has been around for decades. Yeah. It has been improved. It's very efficient, very easy to use. You can digitally speak with those machines. You can have them interact. So it does. There is a good reason that those PCP pumps are being used, but still, this is innovation that can happen. Right now, we're happy with it. It works beautifully, so it's not very high up on the list, I'd say. But I do see potential there.
And what about delivered concrete rather than mixing on site?
I mean, that would be that's something that I guess again the whole industry is looking at, right? That would be exceedingly nice if we could do it from all sort. I mean, cost wise, logistics wise, sustainability wise, it would be very, very beautiful to do. that will remain a technological challenge for some more time to be able to execute that. And I think not to be able to execute it in a lab space, that's always one thing, to be able to stack a couple of layers of them or even a lot of layers in a lab space. But then, okay, you have one concrete truck coming in, and the next one is in a traffic jam, and the next one is out there in the sun, and so how do we incorporate that, and how do we then again do all of this quality assurance? I think that will be the challenge here. So not the proof of concept will not be the challenge, but to bring it into the real world of construction will be a challenge.
As we conclude, come to the end of this podcast, how can people reach you if they're excited about a project, and how can they approach you in an intelligent, comprehensive way, rather than just saying, I want a 3D printed house for $10,000?
Please visit our homepage, peri3dconstruction.com, reach out to us, and we would obviously love to know what exactly drives you. Why do you want to use 3D printing? What do you think is the value in it for you? Do you have a specific project in mind? Are you just interested a little bit to learn? And all of those is fine. I mean, you will get that information from us in terms of what we can offer and what the technology can offer. But the more we understand what problem you're trying to solve with the technology, that would always help us, because obviously we are not the only smart people out there, and I think that other people have great ideas of how we could use this technology and what problem it might be solving. And we'd be exceedingly interested to start a conversation that way.
Would you prefer they approaching it from that very high level perspective of their motivations, or would it be helpful for them to have some kind of sketch or design of what they'd like to print?
Both can be very helpful. If they have a sketch and say, look, this is the size of structure that I want to print, does it make sense? Of course, that's very helpful to understand it. But it's not needed. If you don't have a project specifically in mind and you don't have a sketch yet, that is also can be beneficial, because then we can first try to educate in terms of where we think 3D printing can add the most value and to what type of structure, and then we can start it that way.
Awesome. Well, that concludes the first and probably the only in-studio podcast. I don't know how many other 3D printed construction CEOs will be here in Houston anytime soon, but thank you. I appreciate you joining me today, and I'm really looking forward to seeing the progress of the print you're working on now and all the prints you're going to be building in the future. Thanks.
Thank you very much, Jared.